Hello, and welcome to our video on the reaction list instructions for SN2 reactions. This reaction list is going to be a little bit different than future ones, and it's our first time doing it, so I figured it warranted a little bit more explanation. Of course, you can read the instructions, but I'm just going to go into a little bit more detail in case there was any confusion, okay? All right, so the first thing that we're going to look at is, of course, the due date, so it's going to be due on synthesis day, so as it says right here in the top, and then it's due before class. So that's going to be an hour before class is 9 a.m. So that's when it's due. So make sure you put that on your calendar if you haven't already. So what we're going to do is there's several things we're going to do for this assignment. So the first thing we're going to do is the instructions say we're going to make a reaction list, as you can see here at the bottom. And that's going to be reactions only. So we're just going to make reactions. How are we going to know what reactions to make is going to be these nucleophiles that are listed above. So if you see there's strong nucleophiles on the left and weaker nucleophiles on the right. And there's actually a couple of them. So they go down columns, but there's actually on this side we've got this many, and then on this side we've got this many. So those are all the ones that we need to make sure we do. Okay? So the formats of how you're going to make the reaction is a little bit different depending on if it's a strong or a weak nucleophile. So let's talk about that. And just as a reminder, we did talk about examples of these reactions of a strong nucleophile versus weak nucleophile in class the other day, so you can check your class notes or check out my video on that. So first, what we're going to do for the strong nucleophiles is I've written them as they would act in a mechanism, right? They have a negative charge. But when you have a reagent, you actually have to have a counter ion because like I'm going to buy it at the store, basically. So when I buy it at the store, it has to have a balanced charge. So generally that's going to be covered up by a metal of some sort. And I just usually choose sodium. You could pick other ones, but the cheapest ones tend to be sodium. So you're going to add sodium to that and take away the negative charge. And that's what will go over the arrow, the reagent arrow. The other thing is some of these have R listed on them. Remember we said that R just means it's a generic substitution for some amount of carbons, right? It could be like 1 carbon or 10 carbons. They could be branched or not branched. So basically you just want to add some carbons for anything that says R. I tend to have a go-to R group, so I tend to add ethyls just because it makes it short and easy. So as you can see at the examples on the bottom, that's exactly what I did. So I took for OH minus, that'd be like number 1. That's going to be sodium hydroxide right here. And then when I put it in the product, the OH replaces the Br, like we expect. And then for the R group, I just added 2 carbons for the Br. You can have any starting material you want on the left side. I just chose 2 carbons because it was easier, but you could have like 3 carbons or a ring or whatever you want, as long as it's not aromatic or a double bond or anything, okay? So then on the second one, that'd be number 2, it says OR minus. So I put a sodium over the O, right, where the negative charge was. And then I also put the R group, so I just added 2 carbons for that. So that's what I did for that one. Hopefully that makes sense. All right, so now let's see what we're going to do for the weaker nucleophiles. For the weaker nucleophiles, they don't need a sodium or anything because they don't have a charge. So you're just going to keep those as they are for the reagent, the thing that goes over the arrow. Just leave it like it is. What's going to be different about these is when you do the product, if you'll remember from the mechanism, there's 2 steps, right? First, it does an SN2, but then because that would have a positive charge, it has to remove a hydrogen by doing a strong acid-base reaction. So that means in the product, you're going to react it at the lone pair, so that's where the O or whatever comes into place. That's going to attack at the carbon with the leaving group, and then you're going to take off one of those hydrogens. So I'm connecting it at the atom with the lone pair, then taking off only one of the hydrogens, and then that should be your product. So here's an example here. Of course, the other thing you'll want to do is replace any R groups with carbons, just like we did before. So just remember to do that if there's R groups. You may have noticed, fun fact, that some of these have more than 1 R group for the nitrogen and the phosphorus. So if you're going to do that, you can have 2 of the same R group or you can have different R groups. It doesn't really matter. Like for example, if I did this nucleophile for 15 here, I would draw it like this and it would look like that. And then the product that it makes would then look like this. Okay? So let me know if you have any questions on the reaction list part. Now, as I said before, the reaction list should be only reactions. So they should all be listed like in a row. Line up the columns of starting material, reagents, and products. So make sure you have enough space for that. You want to line them up so that when you're studying, you can cover a whole column at a time. And that's kind of like a flashcard, except for you're only covering one part of it and not like 2 sides. Okay? Let me know if you have questions about that. So then the next thing you need to do, number 2, is going to be the mechanism. So let's talk about that. So as it says in the instructions, on a separate sheet of paper, you're going to draw all your mechanisms. So these you can line up if you want to, but it's not as big a deal if you take more space or you need to not line them up, because you're not going to memorize the mechanisms like you would the other things. The mechanisms, it's more about learning the pattern, right? So for the mechanisms for each reaction, you're going to draw the reaction on top, and then I would draw the mechanism down below it, or like off to the side is fine. So if I was going to do for strong nucleophiles, it's going to be a little bit different than for weak nucleophiles. So remember, for the strong nucleophiles, I'm going to have to redraw the reagent as the negative nucleophile. So basically what I have in the upper left. So if I was going to do that for number 1 here, the mechanism would look like this. And that's all I would need to do. Write the purple part and then write the same thing I did in green, only change the nucleophile based on what the nucleophile is. Just like before, if you change the nucleophile R group, then you need to keep the same R group that you had for your reaction list and just keep that on there. So basically number 2 would look like this. Now, also remember that for the weak nucleophiles, the mechanism is going to be different because it's going to have 2 steps, right? So it's first going to have the nucleophile attacking the SN2 part, and then it's going to have an acid-base reaction. So if I look up here at the example with water, it would look like this, where first I'm going to have the lone pair, draw the lone pair, then have that attack the carbon with the leaving group leaves, and then underneath you can put the acid-base reaction. Remember that you want to have whatever your nucleophile is be the base in that acid-base reaction. So don't add any nucleophiles, don't add any water to it. If it's nitrogen, use whatever it is. So like this NH3 example, I'd use NH3 as the base in that second step, okay? So just let me know if you have any other questions. Hopefully this video helped clear up some of your questions, but if you still have some, just let me know. You're always welcome to send me a copy of what you're working on as well. If you want me to check them, I'm happy to do that even before due. All right, so hopefully this helps. Have a great day. Bye.